You welcome to another episode of Black Guy Does Physics, where sometimes these problems are baby food. Delicious. If you want to ask me a question, help with some math, some physics, just drop a comment at the bottom while you're there. Like, smash that button, subscribe. Yeah, man, just chop it up. Talk that ish. Talk that ish, brah. Okay, with that being said, let's get it cracking. All right, today we're going to be looking at, I think this is 2017, number 3, and mechanics, that is. And this once again is from my boy Spicy. Spicy been having me working overtime. So as always, when we look at these problems, we try to look at the diagram we don't want to read first. We want to look at the diagram to see what's popping. So I see a ramp, and I see a ramp here with an angle and a distance. So angle, distance. So that means I could calculate height. And once I see height, then that tells me automatically that I would be dealing with some energy problem here. Chances are. And then you could see the peep. If you peep right here, they're giving you the mass and the radius of this thing. So chances are this thing is going to roll down. And if it's rolling, then they're going to mention something like rolling without slipping. And if that's the case, then you have to remember that you probably can be dealing with some torque. I don't know. And if you're dealing with torque, then you're probably going to be dealing with forces. If you remember about torque is like R cross F, or F perpendicular R. What's that thing called? The friction will be applying the torque to the thing. That's if they're asking you this. I don't know, bruh. And then this would be also, you could write that as I alpha, and the relationship is A is equals to R alpha. So that's some junk that pops up in your head if they go that route. I don't know which route they're going to go. We'll see. Now, so that's energy. Probably could slide in some motion there, but you don't want no motion. You don't want that pressure, son. So here, I see this thing shoots off the table or whatnot. So that's a dead giveaway, bro. That's projectiles. Nice and easy. That's projectiles, and you should know how to do a projectile. And chances are this is going to shoot off straight across, and if it shoots off straight across, then you should know automatically that your v0x is equals to the speed of what it shuts off, and then your v0y is just 0. So those are good to go. All right, great. With that being said, keep it moving. So we read uniform cylinder. Mass this, radius this, release from rest, obviously. What means that would be 0. Rolls without slipping. As we said, if it rolls without slipping, then what rolls without slipping means is that there's a couple of things that this means. This means that V is equals to R omega is true, because if it's rolling without slipping, then the linear speed and angular speed must be related by that. And also the friction is causing the torque. Now, I know that writing is kind of crappy, but I'm speaking, so you could always rewind this stuff. A lot of kids will think that the weight of this thing was causing the torque. No, it's the friction. The friction is the thing that is turning this thing down the ramp. It's not the weight. They give you the length of the inclined plane. So if you have the length, then you could figure out what this height is. The height. What the hell would the height be? Is that opposite side? So that would be sine, right? So 1 opposite over hypotenuse gives you sine, right? I'm having a brain moment here. So my opposite sine would be equal to, opposite would be h sine the angle. So it'd be 1 sine of 30, or 1 meter sine of 30 would give you my h. So I could figure out what the height is. And then it falls 70.75 meters off the floor. Angle is 30 degrees. Falls a distance d. So obviously they're going to ask you to calculate d or something from the edge. So figure there's a smooth transition from the plane to the, and the motion occurs with no frictional energy loss. Rotational inertia. They give you this, mr squared over 2. Good. So now, question. Calculate the total kinetic energy. Notice they said total. So if that's the case, then easy. Energy problem. When you're solving an energy problem, what you want to do is that you want to know your initial position, your final position. This would be my initial position. This would be my final position. And I want to set my y is equal to 0, my reference line. So this is my reference line because I'm looking from here to here, right? So now all I do is just set up this equation. Now, most of you probably will know the straight up thing to do here, but I'll set up the equation just for explanatory reasons. So you're going to have your u's plus your k's is equals to your u's plus your k's plus the work done by a non-conservative force. This is your initial and this is your final. Remember, there are two types of u's and there are two types of k's. So obviously in this particular case, you have the gravitational potential energy because you're above this thing. So that gives you mgh, and h you could find as sine of 30 or whatnot. There's no spring potential energy, so there's no spring that you need to write, because remember there are two of these. You have UG and US, which UG is the gravitational potential energy, US is the spring potential energy, and you have two of these, which is your kinetic energies, your rotational and your translational. But they're asking you for the total, so you don't have to split this junk up, right? But in the beginning, it's not moving, so this almost cussed. This is for 0. This goes to 0. I almost cussed. At the end, you can see that there's not going to be any gravitational potential or no spring. No gravitational potential because it's at your y is equal to 0, because that's your reference line. And no spring because ain't no damn spring there, bruh. So that goes away. So that's 0. At the end, it's actually moving. It is moving. And it is actually rotating too because it's rolling down here. So it's moving, rolling. So therefore, it will have some kinetic energy. You don't have to split those up at this particular point in time. Oh, this shouldn't be zeros. Oh, Lord. Why is my, because I was erasing something before. That's gone, that's gone. So you're going to have that. Now, here, a lot of kids think that because there's friction and this thing is, the friction is causing this thing to turn, then there would be work done by friction. There's absolutely no work being done by friction on the object. There's a simple explanation for this. The friction that is causing this to turn is static friction, which means that the friction is being applied to one point at a time. The wheel isn't actually sliding over a distance. So because it's not sliding over a distance, then the friction isn't doing work, because in order for the friction to be doing work, the friction must be acting over a distance, which it's not. Therefore, when an object is rolling without slipping, then there's no work being done by the friction on the object. Okay? So if that's the case, then we're done. We're nice and done. The K should be equals to mgh, and you could find h. H, as we said, was sine, so that just mg sine theta times 1 meter. Yeah, so it's that. Punch that in, you're good to go. Dope. All right. I like this. Foods for the babies. Calculate the angular velocity of the cylinder around the axis of the moment it reaches the. Calculate the angular velocity of the cylinder around its axis the moment it reaches the floor. Well, this is a trick question. They kind of trying to trick you here, because it said when it reaches the floor. The trick in it is that once this thing leaves off this counter, there's nothing that will stop it from actually continuing to turn, right? So there's no external torques on it. If we're ignoring air resistance, there's no external torque that's going to stop it from turning. So whatever rate it's turning here will still be the same rate it's turning here. You see what I'm saying? So they put it at the floor to trick you. So all they're really asking is what's the rate here. That's all they're asking. And if that's the case, you know that the Ke, the K that you just found, is going to be equals to the Ke for the translational plus the Ke for the rotational. And you could split those up as 1/2 mv squared, because remember, you found this value here. It's just the gravitational potential energy. Now we're splitting them up. plus 1/2 I omega squared. The problem is you have omega and you have v, so therefore you have to rewrite v in terms of omega. And remember what we said up here, if the thing is rolling without slipping, then v is equals to r omega. So all you have to do here is just do 1/2 m. That would be v is equals to r omega. Therefore, it should be r squared omega squared plus 1/2 I, which is now mr squared over 2. I'm inserting what is there, mr squared and omega squared. And from that, you could just add those up. I think that's like 3/4 mr squared omega squared. You just add them up, and then you just solve for whatever omega is. I am not going to solve through because I don't have enough space, but you could do that on your own. I'm just explaining how you do that. I'm not here to do your work for you. All right, calculate the ratio of the rotational kinetic energy of the to the total kinetic energy of the cylinder at the moment. That is, so if you're doing the ratio, that becomes very trivial, man. It's just ratio of the total, so it would be KER over K. Whatever the two numbers are, you just divide them. That's what ratio means. Ratio just means one thing over the other thing. That's all you have to do. One thing over the other thing. That's it. Divide out the numbers. I don't know what the numbers are, but you got numbers. You got M and R and all that, so you can punch numbers in and solve. That's what it is. Okay? So you'd have to, let me be very careful here. You'd have to figure out what this stuff is because you already figured out what omega is. Okay? So you would have to figure that out. You have what K is, then you'd have to figure out what 1/2 I omega squared is because you just figured out what omega is. Nice and easy. Hopefully it's nice and easy. I'm here talking junk like it must be nice and easy. Now, it says calculate the horizontal distance. Then that is now cake. Why is that cake? Can I cut this? Yeah, I think you gotta cut it. Let me cut this. Copy. And let me put this here. No, that don't make sense. I think I could erase this. No, I can't erase it. Whatever. You're going to see here, whenever you have this stuff over here, then this is going to be shot straight off. As we said, it's right there. I didn't even need to do that. It's going to be shot straight off. And when it's shot straight off, once again, what you know is automatically true. Whoa, where did my stuff go? I'm a mess. Once again, that's where it is. Once again, what you know is automatically true. So let me put it up here. What you know is automatically true is that your V0x is equals to your speed that it shoots off with, and your V0y is equal to 0. That's just automatic. Everyone knows that A is equals to negative G, or G downwards. If you put down to be negative, then it would be negative. Right? And with that now, what you can do if you're trying to find the distance, since you're talking about projectiles, whenever you're looking at projectiles, you always look at it in two ways, horizontal and vertical. To start with whatever they're asking you. In this case, they're asking you for distance. The horizontal distance, D. Let me shrink this. The horizontal distance, D. So if they're asking you for the horizontal distance, D, then you'll start in the horizontal. Now, in the horizontal, there's only one equation. And that equation is that V0x is equal to x over t. The reason for that is due to the fact that the acceleration in the horizontal is 0. Because the acceleration only is in the vertical. So the speed is constant in the horizontal. Because the speed is constant in the horizontal, this is the only equation that you could meet. That means that everywhere in the horizontal along the path of the thing, it has the same speed, horizontally speaking. So your x is your d, so you'd need to find t, and you'd need to find this chunk. Those two things you need to find. Now, the speed v0x, it is the speed that it shoots off with. So I think you already found somewhere up here. You'd have to find the v from here. But if you figured out omega, then you know v is equals to r omega. So if you know omega, then you could say that you could figure out v. So that v that you calculate would have been the speed that this thing shoots off with. That's the speed that it shoots off with. So I'm saying? And you'd get it from here. You did the calculations here somewhere to get omega. Cool. Now you have to figure out the time. So the question now is, where do I get the time from? Well, the relationship between the horizontal and the vertical is that the time is the same. That's the relationship. So the equations here are Vy is equal to V0y plus AT. What is this? Vy squared is equal to V0y squared plus 2AY, and y is equal to V0yt plus half AT squared. So you have these three equations, which are just the equations of motion. Along with this is also an equation of motion. But this is the equation of motion whenever you have a constant acceleration. So you have to use one of these. Notice I put the subscript y to indicate that you're just talking about the vertical. The y is the y here, and the y here is just the vertical displacement. Remember, you're talking about displacement, so direction matters. If I'm searching for time, then this chunk I can't use because there is no time in it. So now I'm going to try and check to see what I know. I know A, right? I know my V0y is 0 because it shoots off horizontally. I don't know what Vy is. Then I go like this now. I know that this goes to 0 because V0y is 0. And I know A, and I know my y. My y would be, if I take down to be negative, then my y would be negative 0.75 meters. So now I have the y. So my y is equals to half AT squared. And you should have seen this somewhere in your studies before. Therefore, t should be equal to the square root of 2y over a. And you could take down to be positive if you want. So you're going to stuff that in there because your distance now is going to be equal to V0, which is R omega, times your time, which is 2y over a. And that would give you your distance. Hopefully you caught that. If not, then rewatch this thing slowly. That's how you do projectile motion, especially when they shoot off straight. That's baby food, son. A sphere of same mass and radius is now rolled down the inclined plane. So it's the sphere. The rotational inertia of the sphere is 2/5 mr squared. So it is less than that. I think it's less because it's 2/5 less than a half. I think so. Yeah. Is the total kinetic energy of the sphere at the moment it reaches the floor greater than, less than, or equal to the total kinetic energy of the cylinder? So notice they said total. So once again, it has to be equal to. Since, why? Because the energy is conserved. And that's easy. If you look at this thing here, let's go back up to the top. Now, make my thing a little bit bigger. Now, if I erase all this junk, now you could see if I look at this, this would be my initial position. And now this would be my final position. Right? And if I look at it in terms of what's happening, then up here, it's totally potential. And if I pick theirs to my y equals to 0, then down here, it would be total kinetic. So in both cases, it's the same because I think they said that the mass is the same. So it has the same height. It has the same mass. So all the potential energy would be the same. So when it gets down to the bottom, it still would be the same total kinetic energy. So obviously you're going to know that something is going to be off because of one is a sphere, one is a cylinder. So obviously they're going to ask you another question. Is the total rotational kinetic energy of the sphere at the moment it reaches the floor greater than, less than, or equal to the rotational kinetic energy? The answer, I think, would be less than. The reason why is because if you look at the equation here, this equation, then you could see that the thing that contributes to how much the rotational kinetic energy is this stuff, the moment of inertia. So if the moment of inertia is greater than, it will have more rotational kinetic energy because it's going to take more energy to rotate it. So in this case, because the sphere has a lower kinetic and lower moment of inertia, therefore its rotational kinetic energy would be less. Is the horizontal distance of the sphere traveled from the table to where it hits the floor greater than, less than? The answer would be greater than. The reason why is because of what we just said. So it will have more KER, so your KER will go up, which means that your KE would go down. This is for your the cylinder. The cylinder, it has more KER because it has a greater moment of inertia than that. So that means that it has less translational kinetic energy, which means that its speed, because remember this junk is 1/2 mv squared, so that means that its speed would be less than that of the speed of the sphere. So if its speed is less than that of the sphere, and we see that v is equals to d over t, then that means that the distance, therefore d should be equals to vt. That means that the distance that this thing is going to travel is going to go down less because the speed that it travels is going to be less when it leaves the table, because more of the energy it's going to be used to turn it than that would be of the sphere. Yeah, man? So I think that's it. Is it? I think so. As usual, kids, don't be a moo-moo.